Hello and welcome to the Esri 2021 Virtual Users Conference. My name is Philip Melke. I'm the 3D Web Experience Product Manager, and this presentation is 3D on the Web with ArcGIS. I am pleased to say that I'm joined here virtually by Janet Baracel in our Zurich R&D Center. Janet, why don't you introduce yourself?
Thanks, Phil. And hello, everyone. My name is Janet Baracel, and I'm joining you from Switzerland today. I'm working on the CMUR as a senior software engineer, and I'm super excited to show you our product today. So let's get started with an introduction for 3D across a platform from Phil.
ArcGIS users can create, visualize, and analyze 3D layers with large volumes of content, like this, achieving high performance, realism, and accurate analytics on the web. 3D is a core GIS capability across ArcGIS clients, industries, and developer experiences. And we believe that a modern GIS is 3D. 3D layers are items that can be managed within ArcGIS and that participate in standard enterprise update versioning and collaboration workflows. We're not doing things for 3D that's so unique to it that it has to exist outside of GIS. Kind of proper GIS data management and maintenance practices. Partners and data providers can create 3D layers with tools that are provided by Esri, or they often implement ArcGIS specifications in their own data pipelines. While for many attendees this can seem new and maybe counterintuitive to the way that you're used to understanding and working with GIS, at Esri we've been making the commitment to utilize the knowledge, software, and data that you've invested in applicable to where you take GIS in the future. This presentation is designed to acquaint you to new authoring experiences with very familiar patterns. We'll discuss the user interface, data types, and publishing, styling and symbology, new editing experiences, interactive analyses, and configurable applications. Now to begin, Janet is going to introduce you to the Scene Viewer user interface.
Thanks, Phil. So I would now like to give you a quick introduction to Scene Viewer, the 3D web tool to author web scenes. But before that, a quick note. I know that we usually have a very diverse audience for this session. There's those of you in the audience who really are new to Web 3D and who are looking for an introduction and want to understand what you might be able to do with it. And then there's those of you who have a lot of experience already with Web 3D and the Scene Viewer, and they want to see really the latest features. And be assured that we will try to cover both. And for those of you who have a lot of experience already, just bear with me through this quick introduction. This might be very familiar to you. So first, let's get started with where to access Scene Viewer. Scene Viewer is part of ArcGIS Online and ArcGIS Enterprise. It's important to mention that a lot of the latest features that we are showing today have just been released with ArcGIS Online 9.2, and they will be in ArcGIS Enterprise 10.9.1. So if you go to your platform, you'll see that there's a scene link up here, which brings you directly to Scene Viewer. We also appear in the app switcher. So amongst the other apps like the Map Viewer Classic and the new Map Viewer, you'll see Scene Viewer. Or you maybe have your feature layer already that you want to open in a 3D scene. So you can just head right through your layer, go to Open in Scene Viewer, and it will be shown in there. But let's have a look at the actual Scene Viewer. When you first open it, we have our tools on the right. These are what we call the viewer tools, and they will be available even if you just share your scene out with the public, and they don't have any accounts on ArcGIS Online or ArcGIS Enterprise. So you have your search, your layers, your base map gallery, the daylight tool where you could adjust the time of the day and your shadows. We have some analysis tools, and I will give you a quick demo of some of those later. We have our sharing dialog where you have access to a short link to the scene. Maybe you want to embed your scene, or you want to create a web app. And the last is the settings. Then on the other side are the authoring tools. So this is our designer panel. So we have here our layers pane panel where you can add your layers and remove them, and you can style them. And this I will show you in a later demo. We have our slides panel, which allows you to store different viewpoints of your scene and layer visibilities and also daylight settings to better present your scene. We have the scene properties where you can change the name of your scene, your tags and summaries. You can save your scene, of course. And we have our What's New dialog, where we show you every release, what new features we've released, and the link to the blog where you can read more about them. But let's go back to the layers pane. Now, before I add a layer, I actually have to make the decision whether I want a global or a local scene. So what's the difference? Global scenes are great, of course, if you have data that spans across the globe, let's say some weather data. But of course, also if you have some rather local data of a county or a city, or you can also use a global scene to give some context where it's situated. If your data is in WGS 84, Web Mercator, or a few other spatial references, you can show it in global scenes. But for most other spatial references, you might require a local scene. There you can use whatever spatial reference you want, and you can also clip your scene. So you can really focus your scene on just where your data is situated. But let's add some data to this global scene. So I head over to ArcGIS Online, where you find all these different layers, and I just add here the United States state boundaries to my scene. So this is a polygon feature layer that now shows up in my 3D scene. And now I could go ahead and show you how to style and configure this layer. But before we do that, Phil wants to explain to you a little bit more about what kind of layers you can actually add to a scene, and especially all the different kind of 3D layers that you might not know yet. So I hand back to you, Phil.
Thanks, Janet. So now we're going to take a look at the differences in all the different kinds of data that you can display within Scene Viewer. Well, this is going to be a tough one. This is a lot of information that we're just going to ultimately gloss over here to give you a perspective as far as how to understand a strategy for authoring scenes with feature layers and scene layers. There's another session here at UC creating and sharing content with 3D that we definitely suggest that you attend for a deeper overview here. But what I want to talk to you about is the understanding feature layers and scene layers and how they apply to your authoring experiences. So feature layers are really something that you've been used to working with all along. It contains geometry and attributes, and it's the standard data delivery mechanism within ArcGIS Online and Enterprise. If you made a 2D map, you touched feature layers. Now, they also have a secret life in that they can be Z-enabled. You can store three-dimensional data with feature layers as well. Scene layers are a type of data that's really optimized for large volumes of 3D data. And there are many different types of scene layers, and they have their own kind of standard for delivery. They're cached data, and they're cached in a way that's pyramided with multiple levels of detail, not unlike the way that you would think about pyramiding a raster for quicker imagery delivery, for example. So feature layers, points, lines, and polygons, as I mentioned, they can contain Z geometry. You would use this for displaying data that could be frequently updated, sometimes IoT, real-time data. There are specific symbolization and smart mapping styles that Janet's going to show you. And there's a lot of different ways that you can author and share and receive this data, work with Survey 123 data or data from a variety of different sources. It is editable on the web, and you can also use views to store symbology or really to obfuscate certain fields for security parameters as well. You can also search them. Now, scene layers, as I mentioned, they're performant larger data, and they have bespoke experiences based on that data, and we'll get into a little bit of that. They can contain imagery that is used to drape within the mesh geometry, and you can edit attributes over the web. You can edit geometry within Pro. You can also create disconnected workflows where a scene layer package that cache can be a mobile scene package and can be read with Earth Mobile. And as I mentioned, multiple levels of detail are generated. So good scenes need a good strategy. Let's take a deeper look at some of those scene layer types. So getting right to it here, point scene layers are points. The example on the top left is showing a space-time cube displayed with a point scene layer, and we're looking through the ways that you can apply a specific smart mapping style to it. Another thing to know here is that we continue to update the i3S spec, so it's very performant. And as this case here in the bottom right is showing with Mammoth, this is 150,000 trees that are symbolized with web styles where the points are storing those locations. 3D object scene layers, This is the case in New York City. It's a classic scene layer that's storing 3D geometry. It can store textures as well, so that you could have textured building where there's images that are covering the buildings themselves. And this is a pretty monumental thing here. We're streaming New York City over a web browser. You can do this on your phone. We have labels for 3D objects is relatively new, as well as different kinds of visualization styles. We have also recently improved transparencies, where you can see we call it order independent transparency, where there's transparent objects behind other transparent objects, and you can see those things. In the case of point cloud scene layers, we're receiving a lot of data this way. The example in the top left is a really interesting one. It's terrestrial LiDAR, which is different than what a lot of GIS folks think about when they think about LiDAR, which is typically, collected aerial LiDAR. A lot of local governments making that kind of investment in it. Now, in the bottom right, what we're going to take a look at here is the Connecticut is sharing their viewer all of their LiDAR data within the state of Connecticut and making that accessible here for their users downstream. Pretty amazing to be able to serve this volume of data. Point cloud scene layer can be symbolized with color, classification, elevation, and or intensity. And in this case here, we're also taking a look at it styled by elevation. Recently, you can do pop-ups on point cloud scene layers so that you can see some of the other information behind it. Integrated mesh scene layer is something that we call like the skin of the earth. It's 3D geometry and imagery coming together in the same place. The bottom right, we're showing a relatively recent capability where we're able to drape features, polygons in this case, over the integrated mesh. Really gives it that kind of feel like it's selectable, but I assure you those are 2D polygons that are just draped over and borrowing the geometry from the integrated mesh there. Mesh modification examples in the top left. This is also something that we've completed in the last year, where you can author masked or replaced. You can cut out certain pieces of mesh and then author an experience in ArcGIS Pro for Scene Viewer that uses this modified mesh. And I just want to highlight here the bottom left. This is data that's captured from a drone. When you think about a lot of the intersection between drone UAVs, UASs, and GIS. Well, that's ultimately what we're seeing here in this case with a lot of data. This is called reality capture. Sometimes it's captured by airplanes and sometimes by drones. Now, this is an example of building scene layer. Now, a building scene layer comes to us from our relationship with Autodesk, which allows us to consume Revit as a data source. And also recently we can consume IFC with Pro 2.8. So in this case here, what we're seeing in the bottom right is this capability of being able to do a building scene layer search, where we can search for room numbers and assets. And really, this data is quite detailed. There's a lot of it there, and this is a great way to be able to interrogate and find specifically what you're looking for. And building scene layers are also, and Revit has been utilized also in the transportation industry and utility industry, and we're finding a lot of our customers approaching this in new and interesting ways, especially in transportation. Here we're seeing that being the building explorer, that bespoke experience for building scene layers is being used to interrogate that data, to identify data that's there at different phases of the construction and other disciplines and categories that we have there, as well as the ability to select levels. So that is a quick run through of our scene layer types.
So now that we know what kind of data we can add to a scene, I want to show you what options you have for configuring that data. This demo will style a layer according to an attribute, and then afterwards you want to configure a pop-up so it goes along with that style. Styling in Scene Viewer uses the Smart Mapping user experience. And for those of you who have not used it, Smart Mapping consists of 3 parts. First, based on your layer and your attribute, we suggest you a couple of templates or layer styles. Once you've chosen a style, we generate smart defaults, meaning we look at your attribute and your layer and we generate statistics and then a visualization that would go along with that. And in the last step, you can actually go in and fine tune that. So change color ramps, sizes, and the mappings. So let's look at an example in scene viewer. I've already created a global scene. We are looking at Europe right now, because the data that I've chosen to demonstrate to you is in Helsinki. I also created a couple of slides, which you can see here on the bottom. So we can easily go to that location and switch on that layer. I have a polygon feature layer here. And these are the footprints of the building of the downtown Helsinki. And you see they have a whole bunch of attributes attached to them. And I want to use the solar electricity potential to make a visualization that tells me which buildings have the highest potential to generate solar energy. So let's go into that layer. Here's our footprints layer, and I go into the layer style to style my layer. And right away, it already gives me a couple of styles that I could apply. In my case, I wanted the style to be driven by an attribute, so I select that attribute. And it took statistics of what the data in my layer actually is and already generated me a visualization. Now, if I go a bit closer, I see that, of course, we only have footprints here. So I want to actually make this a 3D visualization. So I head over to the 3D counts and amounts. And this, by default, will just extrude those footprints to a fixed height. Now, I know that in my data, there's also a height stored per building, and I want to use that one for the visualization. So instead of giving it a 6-meter fixed height, I select the measured height attribute in this height element here. And now you can see that each building has its actual height. Now I might also want to change the color, because solar energy often is associated with green energy. So let's give it a green color ramp. And let's turn on edges. They further enhance, especially visualizations where we don't have textures. And maybe in this case, I actually want slightly thinner edges. And we're done with styling this layer. So you might have noticed that I also have a second layer in the scene. The Helsinki buildings textured is a scene layer. And I want to show you how I can apply the same styling to this layer as well. Very quickly, I want to go through the layer style, pick my attribute. It automatically colors the buildings. And I can again change my color ramp to be the same as the other one. Now this layer has an additional option, which is the texture option. You might have noticed that when I applied the style, it automatically removed the textures and just colored the buildings. I can choose to color the textures themselves, but for this kind of layer style, it is fairly hard to read, which is why we default to color only. There's other occasions where maybe you want to only color certain kind of buildings and gray the other textures to make them stand out more. But in this case, we do the color only option. Now, those of you who published scene layers in the past, you might know that until now, there was no possibility to configure a pop-up once your scene layer was published. From 9.2, you can actually directly in Scene Viewer change the pop-up configuration of your scene layer. So I'm going to show you the example. So here we have this pop-up that by now basically shows all attributes that are defined on this layer. For the current layer styling, this doesn't really make sense. We really want to focus our attention on the solar potential. So let's head into the layer properties, where you can define a whole number of things. Apart from the pop-up configuration, you can also change transparency, your visibility range, and you can filter your data. But let's now configure the pop-up. If you have a look at this user experience, those of you who use the recent map viewer might recognize it. We used the exact same user experiences and ported it to Scene Viewer. This allows the user to use the same all across the platform, and there's no need to relearn a user experience or workflow. So as we look into our pop-up, there's lots and lots of fields, and we really only want the solar potential and the address. So first, let's pick the fields that we want to display. Quickly deselect all, and then select the address, and search for the solar property, edit, and now we have already a much reduced list. But the naming often is not very intuitive, so we want to adjust this for the pop-up. This then becomes much more readable and easier to follow for someone who opens this pop-up the first time. And now we're done. Now, of course, you also have options like adding a chart, an image, or text if you prefer. But for this demo, we are finished. Now, there's one more thing. I'm happy to show you in this demo that you can now not only save all your changes you made to the scene layer into the web scene, but if you have the right permissions, from 9.2, you can also save those changes into the layer item. This goes for scene layers only, and it means that if you have saved this layer, all the styling, all the pop-up configuration will be saved in the layer item, and that will be shared with all the users that you share this layer with. So as an administrator, you can now really configure your scene layers as you wish, save them, and share them with your users without needing to share a web scene. So as a summary to recap, this demo showed you how you can style your 2D and 3D data. You can use smart mapping layer styles and analyze and visualize your data. For 9.2, you can configure pop-ups on scene layers and feature layers. And it uses the same user experience as MapViewer provides. Also new from 9.2, you can not only save changes to your web scene, but you can also save changes directly to your scene layer item. This allows sharing styles, filtering, pop-up, and many more settings via the layer item. But for those of you who are newer to 3D, they might ask at this point, how do you get a scene layer in the first place? What do I need to do? How does publishing work? And what is specific about scene layers there? So I'm handing it back to Phil, who will explain this process.
Okay, great. Thank you very much, Janet. All right, so now we're going to talk through some publishing patterns for getting all of your great data on the web in order to make some 3D web experiences. Now, these are 3 examples that we want to walk through in order to help you to understand data authoring and publishing processes. These 3 scenarios, the first one here, we're going to just upload a scene layer package directly because I3S, the open specification in which scene layers are created, is an open standard, and we have business partners and third parties that are creating scene layer packages in a wide variety of different ways. And so you may want to just upload those directly to ArcGIS Online or Enterprise. The second is ArcGIS Pro, where we're walking through the scenario where you're processing data into a feature layer that you're then publishing as a scene layer for that enhanced performance. And third is ArcGIS Online. We're going to use this great solution feature edit template injection process that the solution team created so that you can have a wide variety of immediately applicable feature edit templates that you can make immediately useful within your organization. Let's take a look. This first demonstration is about as easy as it comes. I'm in ArcGIS Online under My Content, and I'm going to click Add Item from my computer. This is where I'm going to have the chance to choose a file. In this case, I'm going to go directly to my C drive, and I have this cool point cloud here that we have that's derived from iPhone. I'm going to click on this. This is an SLPK. So because I3S is an open standard, we have a lot of different types of third parties that are providing I3S content that is also then immediately shareable on the web. So I'm just going to put a couple of different kinds of tags in here and add this item. Uploading the item, and we're going to see this published as a scene layer. All right, so this scene layer, it's a point cloud now that is directly been posted from that scene layer package that we've uploaded to ArcGIS Online. We're just going to open this in Scene Viewer. All right, and looks like we have success here. All right, for publishing, this is a quick example that I'm showing where I've got 180,000 points that are stored in a table. There's a Z value for plume height above terrain and also the plume height above sea level that we've used for Z values. And we've also got longitude and latitude here in this case. So we're creating a simple feature out of this by utilizing a table to point geoprocessing tool. And that also enables us to create a point Z so that these are 3D shapes, 3D points here that we're going to publish a point scene layer from. Now, we're doing this because 180,000 points doesn't perform very well as a feature layer. So in this case, what we want to be able to do here is to share and share as a web layer. And in sharing and bringing up the share dialog, what we'll see now we'll see the chance to be able to fill in the name for this, and we'll fill out some summary information, tags, and we'll also identify the layer type. So it'll already create a scene layer for us, and this gives us the option to select a feature layer as well. We won't be doing that. In this case, we just want to publish a scene layer. This also gives us the chance to define the folder that we want to be able to save this, and also to set some share settings here so we can share with everyone or with just the specific org that I'm within. We also have a couple of configuration options to cache online or to cache locally. My recommendation is if you have a very large file that you're working within that you can cache locally. I tend to standardly cache locally. That'll create the scene layer package directly on your drive and then upload that. And then here from content, we can just see that we've got a web scene layer and a scene layer package that's going to be created from this one. You can analyze your data and then publish this. Analyzing will just tell you if you have any messages. And when you publish, it'll actually analyze this for you. Let's take a look at what this turns out to be. All right, so now we're just taking a look at that point scene layer that we had published from ArcGIS Pro that was processed from a table. So in this case, you can see now we've got this large point scene layer that has 180,000 points that are representative of a smoke plume model that NASA had produced. Okay, I'm going to show you a quick way now how to create feature layers into ArcGIS Online utilizing a solutions workflow. So in this case, ArcGIS Solutions gives you the chance to be able to use over 500 different kinds of solutions that we have available. I am going to use one that's called the Special Event Operations Plan. And what this is meant to do is to provide assets, locations, zones, routes, everything that's necessary from this standpoint. This is actually going to create feature layers and feature edit templates. And now, using the magic of time, we are going to find a set of features and applications that are specifically designed to help public safety organizations develop safety plans and monitor public safety operations during a special event. So it's great. There's a lot of content and a lot of applications in here that I urge you to check out when it comes to understanding special event management. But in this case, we're going to utilize a couple of features from here, bring them into a scene, and show how you can start editing because these have feature edit templates with them. Okay, so now we have the special event asset feature edit templates that have been injected into this organization through the solutions process. And we also have this integrated mesh of Boston that provides some really amazing context at a very large scale to help us understand and to be aided by the context of 3D with our special event planning template. So in this case, what we're going to do now is to edit. We have points, lines, and polygons within this, so that there's quite a bit. We're going to do some pretty simple examples here in the interest of time. So what we have is a route start. All right, we can add more attributes and context here. And I'm going to continue to search for route, makes it a little easier. So we've got event route. I'm going to draw lines here that are pretty representative of this small parade that we're going to be making. And in that, let's just kind of cut it short here. And we are going to add that. Of course, we can also add other attributes and whatnot. And so once this has been added, All right, and now we're going to signify a root end. This is a point feature layer here. All right, so we've got all of that taken care of. Now we have got features that have been edited in 3D that can give us a overall perspective here, a greater understanding. And because these are feature layers, even though we are aided by this context of 3D, we can actually bring these feature layers directly within a 2D web map experience and be able to make printed maps, even though we did this design process here in 3D. Pretty cool.
So now that we've heard so much about data publishing and all the different layer types that you can add to your web scene, I want to talk about editing on the web, and specifically in web scenes. I want to show you two demos, how you can edit your data in a web scene. The first one is about using the measure tool to correct building height. And then in the second one, we're going to look at some zoning values that need to be adjusted because a new project appears, and we're actually going to draw some plausible buildings on a parcel. But before I start, I want to give you a quick background. The editing capabilities were already released in the JavaScript API last year. And now with 9.2, it's the first time that you can do editing on web scenes inside SceneViewer. So back in SceneViewer. This time I have a realistically styled scene layer of the city of San Francisco. It has all the correct textures for each of the buildings. But I can take this layer and also apply a different style to it. I actually, in this case, took the height of the building and visualized it by color. So now you can see that the darker buildings are the highest buildings in the city, and the brighter the color gets, the lower the buildings are, or smaller. Now, if I look at this building, it is a bit suspicious that its color is rather bright, but it's actually quite a tall building. And I have configured pop-ups for this layer. In this case, I used a text component, and you can see that 333 Bush Street has allegedly a height of 56 meters. This seems a bit small for this kind of building, and I can use one of our analysis tools to validate whether that's really the correct height. We're going to look at some more of the other analysis tool later, but now I'm going to use the measure distance. And I go from the top of the building all the way to the bottom. And I can see that the height is actually 156 meters and not just 56 meters. So let me close this and go into the editing. This icon appears when you have a layer in your scene, and at least one layer in your scene that you have editing permissions on. I open it, and for this layer, I can select one of the features and adjust the attributes. So here it says 56 meters. I'm going to change it to 156 and then update. And you can see how immediately the color changed because the style picked up the change in the data and now shows the correct color. But of course, this is not all. We want to look at a second example, and this time we go to the Mission Bay district. I have a polygon feature layer that is actually showing the zoning values of this area. And it's a pretty dynamic area, as you can see. There's lots of different usage types. If you look at the legend for this layer, we have everything from residential, mixed use, public, and also industrial. There's a project at 2133rd Street that I want to take a closer look at. This parcel here actually becomes a public usage soon. So we want to adjust that value and then put some buildings on top. So first I'm going to go back into my editing. I'm going to select this, some space here, and change the zoning type to public. You can see how it immediately changes. I update. This is now updating the data. And then this is reflected visually also for the zoning color. So now that we have adjusted the zoning value, we actually want to go in and draw a 3D building on top. It's important to mention that what I'm actually drawing here is not a scene layer, but it's a polygon feature layer. And that feature layer only uses an attribute to extrude the polygon to a building. So let me select a 5-story building and draw on this parcel. Snapping helps me to go along the lines of the parcel and to also keep right angles. Here we've added our building. We now edit. But I can not only draw on the ground, I can now also draw a second layer on top of this building. And again, snapping helps me here to stay aligned with the building and to get it right where I want it to be. Now I've drawn basically 2 polygons, and the way this polygon is lifted on top is using z-values to create that offset from the ground. Now I edit, and I'm finished. Now we could publish this project, or share this project with the citizens so they can get a better idea of what the development in this area will look like. Throughout my demos today, I mentioned analysis tools quite a bit. Simio provides a number of interactive analysis tools. In fact, there are so many that I will not be able to demo all of them today. But let's jump right into an example. For this last demo, we go to Zurich, a beautiful city right on the Zurich Lake. I can tell you that I would not want to live anywhere else, except for maybe Sydney. Zurich is a city which doesn't have a lot of high-rise buildings, but when they occur, people get very concerned about what the shadow of this high-rise building is going to do to their building. This is where the daylight tool comes into play. You can look at the different shadows throughout the day, play through them to see how it changes. You can also play throughout the year to get an idea how the shadow is in summer and winter and everywhere in between. But now, looking at this example, it's not quite obvious which of the building is casting how many shadows on this small building in the bottom here. Now you can actually in SceneViewer select a building and it will also highlight the shadow. So you see that mainly this high-rise building is casting a shadow on the smaller one. And this smaller building actually has a smaller effect on it. If you want more about shadow analysis, the API actually just released a shadow accumulation tool that lets you see the accumulation of shadows throughout the day. Zurich is also pretty hilly. And right on the hill where I live, we can make some great use of this new elevation profile tool. So I go into the analysis and over here to the right on the elevation profile. Now I can draw a line right across this path here, the buildings and those trees. And you will see that the tool not only shows me the ground elevation, but also separates out the layer elevation. And with some small adjustments, you now have a really nice visual of what this slope looks like. There's another building in this area that I want to have a look at, which is this one. This roof is actually south facing. And I'm wondering how many solar panels we might be able to fit on this side of the roof. Now I'm going to select the area measurement. And I can very quickly draw a polygon on top here and then leave out the areas of windows, chimneys. And I get a very good idea of how much space I have here for solar energy. I changed to empirical, now you also see it in square feet. Now you might notice that in most of my demos, I actually used the slides on the bottom to very quickly get to different viewpoints. Slides are super useful to give someone an overview of what a scene is all about. But they're not only storing pure views of a scene, they also store layer visibilities. So if you want to show a redevelopment project, you can show your zoning layer, and in another slide, maybe the plausible buildings for that redevelopment. They also store different daylight settings. So if you want to show your shadow analysis in different slides, this is automatically stored. And now that we have really good slides to tell the story of our scene, we're ready to share this scene. You can make it public and share a simple link through our share dialog. You either have a short link here, you can embed your scene, or you can use, for example, the web scene to create a web app. But where you can actually make use of your web scene, for that I hand back to Phil, who's going to show you some examples of applications that use web scenes.
Thank you, Janet. All right, so for the last few minutes of this presentation, we're just going to discuss how scenes are consumed and what can consume them. We'll take a quick look at some 3D configurable apps and also understand where it is that ultimately the creation of a scene resides. A scene is just stored set of pointers for all that data that we talked about creating and caching and hosting in ArcGIS Online and Enterprise, and also potentially editing and working within. But that scene contains the symbology, is what's authored in Scene Viewer, and you can use Scene Viewer to view scenes. There you can explore, analyze, and author and share, as we were seeing. And you can also utilize configurable applications like Story Maps, Experience Builder, Web App Builder, custom code, and custom code your own applications. But there's also other applications that can consume these things. ArcGIS Earth can actually open up a web scene. And let's take a quick look here at one of our new instant apps, which is a configurable app template. To begin, we have this beautiful scene from Esri, Netherlands that contains information about the locations of wind turbines. We're going to share through the scene and then utilize the instant app that we have here. This will bring up a app configuration dialog with an app setup page where first we identify the source. We're switching over here to full setup so that we can see everything. We're identifying the source of the scene and some information about it, some details. We can add a splash panel or a custom header. In this case, I just want to be able to adequately title this application here, 3D Wind Turbines Line of Sight app. The intent of this app will be to determine if we're able to see what's in the distance with some of these wind turbines at sea. Now we're just adding some interactivity controls. An inset map also helps some of your audience understand the difference of where they are between 2D and 3D, which is pretty useful for some of the standard GIS crowd. A little information here about how you can modify, adding daylight information or the line of sight widget and layer list. Now, that line of sight widget is something that we'll utilize here. We can also add searching and geocoding, as well as identifying the theme and how that would ultimately look in mobile devices. So we confirm that we're publishing it super quick. And we're going to launch this application, take a look at how this line of sight widget here in a configurable experience is now accessible to help to solve this use case of determining what can be seen at sea. Really interesting use case and a great way to be able to explore data with new analytical tools. And it's a configurable app template that you can use today. So I want to turn your attention to some work done by the Rice Spatial Studies Lab. This is an experience builder instance that lines up the YouTube videos that have been geolocated from the Beirut explosion, along with a 3D environment to understand the placement of that explosion and the buildings and the environment around it. We're cycling through different features that help to identify the locations of those videos and really where they sit in line with the visualization. Really useful way to be able to really understand that situation a little bit more. And Experience Builder provides a way to interrogate all of that 3D data and make a very useful 3D experience that can be shared throughout an organization or used to ultimately provide navigational experience. Also, here's a custom application, Explore Mars, that we put out just to highlight our capability of being able to consume or to project within the Mars projection. We were really excited about the landing of Perseverance. And what we're showcasing here is how we're able to use a lot of these different widgets, in that case, the profile view. And we also wanted to help people understand the size of Mars and what would happen if you try to put state of California or in some cases, a three-dimensional model of a city like Manhattan on Mars. This app utilizes the JavaScript API and scenes in Scene Viewer. Thank you for attending this presentation. We look forward to taking your questions.